So we're going to start talking about rational functions, creating their graphs, listing their attributes. There are a lot of steps on this page, and you can find this page in your shared notes folder if you need to print a copy. All right, but at the bottom here, we have some sample rational functions graphs. And when we're thinking about rational functions have vertical and horizontal asymptotes. Sometimes they even have slant asymptotes. So you'll look here, I'm drawing some asymptotes, some invisible boundaries in that create the shape of the graph. Okay, so all of 5 of these pictures have vertical asymptotes. 4 of them have a horizontal, and that last one over on the right has a oblique or slanted asymptote. So in this section, we're going to be talking about, how do we find all of those asymptotes? What are domain and range for these functions? And then x-intercepts, y-intercepts, and we'll also introduce a hole. So real quick, before we get into an example, I'm just going to talk about what a rational function is. A rational function is a ratio of 2 polynomials. So if you look at what we have here in the top, this looks really similar to our polynomial definition we were talking about in previous sections. So when I put a polynomial over a polynomial, I've created a ratio. And so I use this standard form here. I'm going to refer to this A, N, C, B, D, and K throughout working the problems. And then talking about all of our definitions on this sheet. So the first thing you always want to do is make sure that you factor, okay? The reason we want to factor is because things cancel. However, we don't want to cancel any factors until we find the domain. And we've been doing domain since the start of the school year, so we all know we need to know what values the denominator is undefined for. So we don't want to cross anything out until we've determined domain. So the domain comes from choosing the values that make the denominator 0. We're going to set the denominator equal to 0, and that will let us know which values we need to exclude. And of course, domain always needs to be written in interval notation. All right, so factoring, finding domain, those are not new steps. All right, so after we've found our domain, this is when we can cancel common factors. We can cross things out, okay? Any canceled factors will tell us that we have a discontinuity. And a discontinuity, we talk about those a lot in calculus. It's just a fancy word for a hole, okay? So, and we'll do examples that talk about what all of this is. But when we cancel factors, whatever we cancel represents the hole. All right, vertical asymptotes. So whatever is left in the denominator, that is going to represent a vertical asymptote. And that's setting by what is left in the denominator equal to 0. Vertical asymptotes are a vertical line, so that answer is written as x equals some number value. And what you need to remember is you can never cross a vertical asymptote. So vertical asymptotes, those are new, and we're going to talk about the horizontal asymptote here. That's the last new thing. When we start talking about finding a horizontal asymptote, we want to use a comparison test. And what we do is we compare the degree of the numerator to the degree of the denominator. Okay, so when I talk about the degree of the numerator, we use the letter n. And when we talk about the degree of the denominator, I'm using the letter d. And if you come up here and look at my standard form, you see there's my n, the highest power in the numerator, d, the highest power in the denominator. So if n equals d, if it's x squared over x squared, or x to the fifth over x to the fifth, or x over x, in that situation, my horizontal asymptote is y equals a over b. And a and b are those leading coefficients. Okay? If numerator is less than the denominator in degree, so maybe we have something to the first power over something squared or cubed, then we will always have the situation where y equals 0. And if the numerator is greater than the denominator, we do not have a horizontal asymptote. We would have an oblique or slanted asymptote. You do not have to find or draw this case for the test, but you might see it in your homework. And oblique asymptotes, we use long division there. All right. Remember, you can sometimes cross a horizontal asymptote. So sometimes my graph is going to cross over that horizontal invisible boundary. But we will never cross over a vertical asymptote. Okay? And you want to notice here where we're talking about these horizontal asymptotes, they're always written like the equation of a horizontal line. We have y equals some number. So the last two things we have to do here are to find the x-intercepts. And we can find the x-intercepts by setting our reduced numerator equal to 0 to solve. We write that as an ordered pair. And the y-intercepts are found by setting x equal to 0 and solving for y. And those are not new steps. One thing you do want to notice is when we talk about linear and quadratic and cubic polynomials, that last term, the constant, like y equals mx plus b, that constant at the end represents the y-intercept. So you'll notice we have a shortcut here. It's the ratio of the constants. So you can plug in 0 for x, or you can just look at the ratio of the constants. So at this point, we have enough information to start graphing things on our paper. If necessary, make a table of values. Make yourself an XY chart and just plug in a number, get out a number. Plug in a number, get out a number. And that will help you find additional points to draw the curve on your paper. You're certainly always welcome to use your calculator, right? Just remember, your calculator will occasionally, depending on how old it is, it might connect lines and draw a vertical asymptote that isn't there, so that vertical part of what I just sketched. And then also when you're typing it in the calculator, you're going to go to your Y1, and you're going to have all of your numerator divided by all of your denominator. And you may have parentheses inside your numerator, but you need to make sure that it's all connected. So the numerator is collected together and the denominator is collected together, because if you can't type it in correctly, the calculator can't give you the correct graph. Okay? So when you draw it, just draw your asymptotes, plot any points the x-intercept, the y-intercept, or the whole, and then sketch the rest of the curve using your calculator or a table of values to help.